So one question that I think is illustrative of the importance of Hardy-Weinberg equilibrium is to ask, well, how long does it take for a population to achieve Hardy-Weinberg equilibrium? And so we can do this experiment just by simulation. So let's take our Italian population, in which we had 84 individuals, and we had demonstrated using the chi-square test statistic that they were indeed not in Hardy-Weinberg equilibrium. And then let's impose a single round of truly random mating. And to do this, we can use a Punnett square again here, and we can think about the male gametes here and the female gametes in the population here. And these gametes have allele frequencies of the A allele or the G allele as specified here, which we had determined using just on the basis of the genotype frequencies. And now we can ask, okay, if we randomly mate individuals within that population, what are the genotype frequencies going to be in the subsequent generation? And so we just multiply together these probabilities. So we'll have a 0.28 for the AA individuals. We'll have 0.249 for these AG individuals. And we'll have 0.249 of the population will be these AG individuals, and 0.221 will be GG. And so again, in this Punnett square now, we can see that there are two ways to form the heterozygote as shown here. And so that's of course why we add them together. And so the frequency now in the next generation of the AA allele is going to be 0.28. The frequency of the GG genotype is going to be 0.221, and the frequency of the AG heterozygote is going to be the sum of these two, which is equal to 0.498. And so you can see that in a single round of random mating in this population, that the population is now in Hardy-Weinberg equilibrium. And so the answer to this important question here is 1 generation of random mating. And this is important because this reminds us that if we observe that the population is not in Hardy-Weinberg equilibrium, then that tells us that something unusual is going on in that population, that it's deviating from our expectation based on truly random mating.